Welcome to the BTM channel's 42nd episode for technology and innovation. We're dialing the clock back to 1977, the beginning of the appliance computer era that featured the Tandy TRS-80, Apple II, and the Commodore PET personal computers. However, the handheld calculator wars, started by Hewlett Packard's 1972 introduction of the HP-35 scientific calculator, had been going on already for 5 years. Hundreds of different calculator models vied for the consumer's attention, and the leading electronics companies offered dozens of models each. Nowhere was this truer than at Texas Instruments, which probably offered the most choices in an effort to saturate the market. As part of this effort, the company released the TI-1000 that year, together with the TI-1025 and the TI-1050, as a cheaper alternative to the upcoming LCD display calculators. The TI-1000 series was Texas Instruments' third generation of non-scientific calculators. The first generation was the famous Datamath TI-2500 series, and the second generation was the TI-1200 series. Within 1 or 2 years after the introduction of the TI-1000, the end of LED and VFD calculators was reached. Modern LCD calculators provided a long battery life and a slim form factor. This episode features the TI-1025. The TI-1025 used a vacuum fluorescent display that was carried over from the TI-1200 rather than the LED display of the TI-1000. Rebadged versions of the TI-1025 were marketed by Western Auto as the Citation and as a private label of the Dutch department store HEMA. The calculators were made in the US, but also in El Salvador, Hong Kong, and Spain. Let's put our hands on the TI-1025, explore its characteristics and features, and compare it to other popular Texas Instrument calculators sold around that time. Alright, so we are reviewing the Texas Instruments TI-1025 calculator from 1977. The TI-1025 is a third generation calculator. They look quite different from the HP-35, which you would have seen in the video, and the Texas Instruments equivalent to the HP-35, which is the SR-50. As you can see, the SR-50, which is their first generation calculators. SR stands for slide rule. We've discussed the slide rule in previous episodes, so I'd encourage you to look for that. The SR-50, is a beefier case, higher quality plastic. As you can see, it's a larger unit. Now, the SR-50 is, of course, a scientific calculator, and the TI-1025 is not a scientific calculator. It's what I would call a bookkeeper's calculator, an accountant's calculator, if you will. Generic calculator only has, unlike a scientific calculator, which of course has all the trigonometric functions on it. The regular bookkeeper's calculator only has memory add, memory subtract, percent, and the basic multiplication, division, addition, and subtraction. And that's all you needed, obviously, for adding up, your checking account, or if you're an accountant, just simply adding, a roll of numbers, to get to foot to a particular total. So completely different functions. Now, both algebraic notation calculators. The HP-35 is a reverse Polish notation calculator, and I encourage you to go to episode 3 to learn a little bit more about what an RPN, reverse Polish notation calculator, does and how it works. Algebraic just simply means that you compute math from left to right using brackets, whereas RPN calculators eliminate the need for brackets in your formulas. So the TI-1025 was they are meant to take the place of the TI-1200 series, and then which was previously replacing the TI-2500. The TI-2500 is the Datamath calculator. It's quite famous among people who are too old to admit it on the camera. It was bought, in large numbers in the early 70s, and eventually the Texas Instruments economized the design and kind of turned it into this. This series is the last bookkeeper's calculator that Texas Instruments made before they released an LCD version called the 1030 in 1978. LCD calculators really took off in 1980, but you could buy them before that. VFDs and LED displays are real battery hogs and just siphon off power like crazy. Whereas an LCD just sips power. It's much different. Plus, the LCD is very flat, so you don't need this, thick calculator. This is a non-working unit. We picked this up at a local thrift store, as we do with most of the merchandise we get. For the sake of this video, we've already partially disassembled it just so that we can take a look at the inside. So the TI-1025 is 5.5 inches long by, call it 3 inches wide, and at its thickest, it's a wedge shape, 1.5 inches at its thickest. If you're wondering where the wedge shape came from, this is not a Texas Instruments innovation. They were following the HP35, which we don't have a copy in this video to show you, but again, check out episode 3. They all follow the HP35's wedge shape. The intent, of course, being slopes down like a keyboard so that you can type in information easier rather than something completely flat. Of course, ironically, now everything's flat. In 2020, phones are flat, and calculators are flat, and MP3 players are flat. So of course they did away with this whole idea. But back then, this was considered to be the way to go. Of course, all personal computers tended to have this sloped design. So that's how large it is. So we'll write it down: 5.5 inches by 3 inches by 1.5 inches at its widest. All right, let's get a measurement here and weight. So 5.1 ounces with the 9-volt battery in it. These units operate off a 9-volt battery, which was okay, even with a vacuum fluorescent display. 9-volt battery has a pretty good energy storage component to it. It's better than a AAA battery, but they did run out back then. 9 volts were cheaper back then, relatively speaking. Now they're very expensive because a lot of devices don't use it anymore, so they're built in lower quantities. So you'd be lucky to find 9-volt batteries these days for less than $2 each, which is just ridiculous for an alkaline battery. But it's just a function of supply and demand. So 5.01 ounces with the 9 volts in it, and then we put the 9-volt battery in it as a standard 1.6 ounces. So call it 3.5, right? So 3.5 ounces to total for this. So very lightweight. There's not much to it, and intentionally built that way. I mean, it's very, very cheap plastic. This is not as expensive calculator either by 1977 standards or 2020 standards. We'll start taking it apart so you can see some of the way it's made. Of course, here is the 9-volt connector. This particular unit did not come with a power pack. The earliest calculators, like an SR50, comes with a power pack. I'll show you what that looks like. So you can see it's nothing more than just these were, I think, 9-CAD batteries. You can see this one's corroded, needs to be replaced. It's not unusual for a lot of the equipment that we have. We get it, and it's not really taken care of. So that's what a power pack is. This one didn't need a power pack. The power pack adds a considerable amount of cost. You have to charge it. It's just a real pain. So the 9-volt was fine, particularly since it doesn't have any sophisticated memory function. It doesn't have to have any sophisticated trigonometric calculations. Back in those days, on a scientific calculator, you could hit the button and it would spend 10 seconds calculating a long calculation, particularly if it was programmable. And you'd burn through a battery pretty quick if it was just simply a 9-volt. But you don't have to worry about it for this battery. So now it does have on the side a port for a 9-volt AC adapter plug. You could buy the 9-volt adapter separately if you wanted that feature, rather than having to use 9-volt batteries. It was pretty extravagant for the time. 9-volt, as I said, 9-volt batteries at those times were very, very, very cheap. So, every transistor radio used 9 volt, and a lot of toys use 9 volts. Anyway, standard layout. As you can see, if you compare against the two calculators at the time, the other two are scientific calculators, of course. We don't have a TI-1000 to show you, or a TI-1050. But the design layout is very similar, even on the scientific calculator. So you can see that, the same aluminum facing, it's like an aluminum inset that has been silk screened or maybe etched with like a slight brass color, or if you will, brown color, made by the TI programmer, with maybe perhaps some additional silk screening to give the second and third function of the scientific calculators. But very similar layouts, very similar sizes. These are a little beefier because you need more keys. The philosophy here is clearly the same. So, and it's intentional. So, you can imagine some drafters sitting over a table, slaving away over, several dozen versions of these. And there were dozens of these TI calculators made between 1973 and 1980. All these LED and VFD calculators. There's just so many of them. Texas Instruments' strategy at that time, which has completely changed, was to develop a special unit for every little niche and just completely saturate the market and destroy basically its rivals. And they were pretty effective at doing that. In this day and age, there's very few other calculator makers, Sharp, Casio, other major ones. And of course, Hewlett Packard still makes calculators. So, naturally, there are other, small rinky-dink calculator makers who make, a dime a dozen calculators that are more similar to the 1025. But for scientific calculators, that at least are accepted by school systems. Certainly, it's Texas Instruments that is the king. And then for engineering schools, TI calculators, Casio, Sharp calculators. But back then, they had all these different calculator types, but all very similar in layout. Rearranging the order here a little bit, you can see that the you went from a bookkeeper's calculator, very simple, to the scientific calculator, to the programming calculators. The microprocessor issue is kind of interesting. Texas Instruments basically designed and fabricated a different microprocessor for every one of its calculators. But so it seems. There are some minor variations. And apparently they thought it was cheaper to use less transistors in certain fab processes for the cheaper calculators and get its own microprocessor, and then more transistors for as they get more sophisticated. I think the TI programmer has something like 30,000 transistors in the microprocessor itself. Microcontroller, really, it's not really a microprocessor, call it microcontroller. So, for example, the TI-1025 used a TMC-0923 microprocessor. We'll look at it in just a second. TI-30 used the TMC-0981 microcontroller. I keep on saying microprocessor. And the TI programmer used a completely different chip than this because it needed more registers for the programming feature, and that used the TMC-0983 microcontroller. So anyway, so the TI-1025 had its own microcontroller that was fabricated in volume for this specific calculator. Apparently that was cheaper. And in today's day and age, that's not the way it's done. Everybody uses a Zilog Z80 variation. It's a variation of the Intel 8088 microprocessor. The Zilog Z80 is the one with the instruction set that everybody uses even 40, 50 years later. The TI-83, TI-84, all those calculators you see for school students these days all use the Zilog Z80. I'm not sure what the most modern Texas Instruments calculators use for microprocessors. Probably still the Z80. So I'd have to look it up. Like the Inspire, for example, I'm not sure what it uses. So let's take a look inside. So it's just a clamshell, as most calculators are, upside down, so you can see it together, side by side. As you can see, the 9-volt power supply it's just plugged right into this circuit board. In these older calculators, the display circuit board and the logic was all in one board, and then it was connected via pins to the keyboard. This is the keyboard pad right here. This is its own circuit board. It's plastic backing, kind of disguises the tracings that are used for when you press the button. Provides signals to the through-hole pins. Here you can see the through-hole pins. me see if I can bend this over so you can easily see. Yeah, here we go. So you can see here, here's the vacuum fluorescent display. It looks like an LED display. It is not an LED display. These big round things are capacitors. Nowadays, a capacitor that's needed for a calculator would be the size, of a pinhead that was surface mounted right to the board. But back in the day, they didn't have that capability. Everything's through hole. As you can see, these through hole tracers, the microprocessor is 3-hole. We'll get to that in a second. So anyway, going back to the VFT, the vacuum fluorescent display is essentially a triode that is a vacuum tube. It's a vacuum tube, like Nixie tubes. If you've ever seen Nixie tubes, for whatever reason, maybe you have a piece of equipment that has a Nixie tube, although probably not. They're made modern day. People make Nixie tubes as novelties. They're very expensive. Back in the day, Nixie tubes were the only way you could display things cheaply enough, and then they replaced them with VFDs. But the principle is still the same between a Nixie tube and a vacuum fluorescent display. It's a vacuum tube in which there is a electrode inside with phosphors on it that glow when currents run through it at the proper voltage. So kind of a fascinating system here. Not an LED display. This is just literally a printed screen, whereas an LED display had like this TI-30. LED displays have, it's hard to see, and I haven't disassembled the calculator, but you know what an LED looks like. It's a diode that's, when you stimulate it, it radiates light. In this particular case, the light emitting portion of the diode is shaped in a numeral, if you will. Whereas here you apply a charge to the vacuum tube. Here's the TMC 0923 microprocessor. Whoop, I can't. Let's get the display. It's soldered right onto the board. Again, this is old-fashioned through-hole solder. Everything is through-hole. It looks to me like just a single-layer circuit board, double-sided, I should say. Not very sophisticated, but it doesn't have to be. Again, these calculators, all the function of the calculator is inside the chip. Really, everything else is just supporting the display being energized by the chip and commands being taken from the keyboard. So that's all there is to it. That's what's in a calculator. Nowadays, calculators are made with just one single circuit board. They don't have this arrangement where you have the main circuit board and then another type of assembly for the keyboard. What they have now is just one flat circuit board. Everything's mounted to it, including the keyboard, and that's all there is to it. But really, the technology hasn't really changed much, other than going to surface mount components, and perhaps the microprocessor may be a little smaller depending on which unit you have. You can see here's the port here for the 9-volt. Just again, it looks like, if you went onto a PC motherboard, it's just soldered right to the main board here. So that's it. So kind of slip it back together again. It just, if you can imagine someone making this, just pops in, someone does circuit boards, and then some guy or gal is just assembling them together with a considerable more facility than I'm doing. I'm showing here. It's like the old joke about plumbers. Everybody calls a plumber because they've done the pipes 1,000 times. So yeah, it pops together. There's no screws even on these units. Modern day calculators, they're generally screwed together just because there's not enough room for the tongue and groove snap togethers that you need to make this work. So there's 3 snaps here, and then some pivot points here, and it just snaps together. And that's it. It's pretty straightforward. So that's it. That's the TI-1025 calculator. Before we get to the concluding segment, take a moment to subscribe if you have not yet done so. The first major YouTube milestone is at 10,000 subscribers, and we are doing everything we can to get to that mark. Help us out by becoming a subscriber so we can continue to deliver great content to you. And please click the bell notification icon to ensure you are notified when new episodes are released. So, can you still buy the TI-1025 calculator? You can. Working examples are plentiful on eBay for about $10, and with the manual and original packaging for about $20. Some listings also offer the 9V AC adapter, although a 9V alkaline battery is all that is required. Texas Instruments still dominates calculator sales in 2020, so it is a simple matter to pick up the 21st century equivalent to the TI-1025. One such model is the TI-108, which is functionally similar to the TI-1025, although slimmer with a solar-powered LCD display. The TI-108 was introduced in 2008. Don't be put off by the 12-year-old intro year. Unlike in the 1970s, in the modern era, Texas Instruments can go years, if not decades, between calculator models. You can still buy the TI-108 brand new on Amazon for about $8, or $5 each in bulk. What did you think of Texas Instruments, its calculators from the 1970s, and the TI-1025? Did you know the company's impact on handheld electronics in the nascent era of the microprocessor? Share with us by dropping a comment below. We hope you enjoyed this 40-second episode on the BTM channel. If so, click that like button. Links to some of our most recent episodes can be found in the description section below. You can peruse our entire 140+ video library by looking at our playlists, which conveniently sort videos by subject. We announce all new videos on our Twitter account, as well as in the community feed for this channel. Want to know how to navigate our channel content? We refer to retrotech and innovation documentary segments as episodes. Coverage of current events in space exploration, science, and technology are labeled as shorts. Space and tech history are documented in an anthology called Milestones. And gameplay recordings can be discovered on the BTM Gaming channel in videos called walkthroughs and side missions. Stay connected by occasionally checking our Instagram feed, where we post content from our upcoming episodes and from episodes past that you may have missed. And finally, join us on our Facebook page, where we cover current news and events related to channel content. Thanks for watching.